Hi, in this video we will derive the equation for moment of inertia of the circle. Okay, for that I have considered a circle of radius r. Okay, let me mark the centroid of the circle. G is centroid of the circle, and let us assume r as radius of the circle. Capital R. Okay. Now for derivation purpose I will consider an elemental ring or the elemental strip. Okay. Okay. I'll consider an elemental strip of radius r. Okay, having radius r. Let me write on this side of radius r and thickness dr. Thickness is dr. Okay. Okay. So I have considered an elemental strip at a radial distance r and thickness dr. Okay. Now in the derivation part, area of elemental strip is equal to now I want the expression for area of the elemental strip. I have taken it as dA. So how to find the area of the elemental strip? Means I want area of only the shaded portion. Okay, that is area of the elemental strip. What you do is you find perimeter of inner circle. Okay, perimeter of inner circle and multiply the thickness. You will get the area of the elemental strip. Okay, so we know the formula for perimeter of the circle, that is 2 pi r. Okay, therefore 2 pi r is perimeter of the inner circle or length of the circle into multiplied by thickness. Thickness is constant on all the sides. Okay, this will give area of the elemental strip. I hope you understood this formula of the area of the elemental strip. Okay, perimeter 2 pi r multiplied by thickness will give area of the elemental strip, 2 pi r into dr. Okay, this is the first step. In the next step, what we will do is we will find moment of inertia of elemental strip about z-axis, IZZ is equal to, where is z-axis here? Z-axis is perpendicular to the screen actually. Okay, perpendicular to the screen. So here we have the x-axis and this will be y-axis, and z-axis is perpendicular to the screen, perpendicular to the screen, and r is the small r is the perpendicular distance of elemental strip from z-axis. Okay, therefore moment of inertia of elemental strip about z-axis is equal to dA into r square, area into distance square, dA into r square. Okay, now Izz is equal to, or we will find the moment of inertia of the whole area now. Therefore, moment of inertia of whole area about z axis is equal to Izz is equal to get the moment of inertia of the whole area, you have to integrate, correct? You have to integrate from 0 to capital R. Okay, if you integrate moment of inertia of elemental strip about z axis with limits from 0 to R, 0 to capital R, you will get the moment of inertia of the whole area, dA into R square. Okay, therefore Izz is equal to limits from 0 to R, dA is 2 pi R into dr, substitute 2 pi R into dr into R square. Therefore 2 pi is constant, you take it outside the integration, limits from 0 to capital R square into R cube into dr. Therefore 2 pi integrate with respect to R cube, R to the power of 4 divided by 4, limits from 0 to capital R. Therefore 2 pi into, apply the limits now, it is capital R to the power of 4 divided by 4, 2 1s are 2 2s are. Therefore moment of inertia about z axis of the circle is equal to, the remaining equation is pi r to the power of 4 divided by 2, pi r to the power of 4 divided by 2. Now we have derived the equation for moment of inertia about z axis. Now we should also derive the equation for I-axis and I-y-y, moment of inertia about x-axis and the y-axis. For that, what we will do is, we will utilize perpendicular axis theorem. Perpendicular axis theorem. Therefore, from perpendicular axis theorem, we know that moment of inertia about z-axis is the sum of moment of inertia about x-axis and sum of moment of inertia about y-axis. Okay, now for circle, the circle is having same radius in all the directions, correct? The circle is having same radius in all directions. Therefore for circle, whatever the moment of inertia about x-axis will be same as moment of inertia about y-axis. Okay, because in x direction as well as in y direction, the circle is having the same radius. Okay, therefore for circle Ixx is equal to Iyy. Now rewriting this equation, Izz is equal to Ixx plus, in place of Iyy I will write Ixx only, Ixx. Therefore 2Ixx is equal to Izz. Okay, so you know the equation for Izz, that is pi r raised to 4 by 2, substitute. Therefore 2Ixx is equal to pi r raised to 4 divided by 2. Therefore moment of inertia about x-axis is equal to pi r raised to 4 by 4. So this is the final expression for Ixx. Okay, it is in terms of radius, the formula is in terms of radius. In terms of diameter also you can obtain the equation, or pi by 4, r is nothing but diameter by 2, d by 2 to the power of 4, which is equal to, let me write below the formula only, Ixx is equal to pi by 4 into radius is nothing but d by 2 to the power of 4. Okay, so pi by 4 d by 2 to the power of 4 means d to the power of 4 divided by 2 to the power of 4 means 64, correct? 64. Correct? 2 to the power of 4 means 2, 2, 4, 16 it is. Okay, sorry. It is 16. 2 to the power of 4 is 16. Therefore, Ixx is equal to pi d raised to 4 by 64 in terms of diameter. It is moment of inertia about x-axis for circle in terms of radius is pi r raised to 4 by 64. In terms of diameter it is pi d raised to 5, pi r raised to 4 by 4, and in terms of diameter it is pi d raised to 4 by 64. Okay, similarly, if you obtain the expression for Iyy, okay, it is the same only. It will be the same equation only, because Ixx is equal to Iyy for the circle. Therefore Ixx is equal to Iyy is equal to pi d raised to 4 by 64. Okay, so this is the final expression for moment of inertia of the circle about x-axis and y-axis. Okay, about z-axis it is pi r raised to 4 by 2. Okay, so this completes the derivation of moment of inertia of the circle. Okay, thank you.